Welcome to This Explainer, serving as your complete job preparation guide for mechanical engineering interviews. Today, we're bridging that massive gap between academic theory and real-world industry practice. If you're a student, a fresh grad, or a junior engineer gearing up for those tough technical interviews, you already know that passing a thermodynamics exam is very different from proving to a hiring manager that you can actually design a safe, functional product. So we're distilling key textbooks and industry standards into a focused masterclass to get you absolutely interview ready.
Here is our agenda for today. We'll be hitting four main topics: core principles, the technical tool belt, industry pathways, and finally, ethics and community. Let's jump right in.
Starting off with Section 1, Core Mechanical Principles, the Foundations. When an interviewer asks you to explain the absolute basics, they really aren't looking for a textbook recitation. Take stress, for example. Don't just blurt out force over area. You want to explain it practically. Stress is the invisible internal resistance a material feels when an external load is applied. Think about it this way. If you apply a 100 kilonewton tensile force to a circular rod, the stress is that exact force distributed across the rod's cross-sectional area. It's the internal burden the material is bearing.
Right on the heels of that, they're probably going to ask you about strain. Strain measures the actual physical deformation that results from that stress. If stress is the invisible internal resistance, strain is the visible physical consequence. It's calculated as the change in length divided by the original length. So in an interview, when you're asked the difference between the two, remember this golden rule. Stress is the cause, and strain is the effect.
Now, let's talk about material memory. Does a material bounce back elastically, or does it permanently yield and become plastic? Elasticity simply means the material acts like a spring. Remove the load, and it snaps right back to its exact original dimensions. But if you push past the yield point, you enter plasticity, which means permanent deformation. And here's a fun fact to drop in an interview. While you usually want operational parts strictly in the elastic region, automotive engineers actually use the plastic region intentionally when designing crumple zones to absorb crash energy.
Here's a classic interview scenario they love to throw at you. Why would you choose mild steel over cast iron? Well, the answer lies in ductility versus brittleness. Ductile materials give you a warning. They stretch and deform visibly before they snap. Brittle materials, like cast iron, absorb very little energy before failing suddenly and catastrophically. So you'd use a ductile steel for an automotive suspension arm that might take a hit, and brittle cast iron when you need extreme rigidity, like for a heavy machine base.
All right, moving right along to Section 2, Essential Engineering Technical Skills, the tool belt.
So, when an interviewer hits you with the classic, "Tell me about yourself," what they actually want to know is how you synthesize these core technical pillars. A strong candidate understands how solid mechanics, fluid dynamics, and thermodynamics interact. For example, if you're designing a jet engine, you absolutely need thermodynamics for the combustion, fluid mechanics for the airflow, and solid mechanics so your turbine blades don't shear off. You want to structure your answers around how you've combined these exact skills on your actual projects.
To predict how things will fail before they are ever built, you need to bring up industry-standard finite element analysis, or FEA. We don't just rely on hand calculations in the industry anymore. We use powerful tools like ANSYS or Abacus to mesh a CAD model and simulate exactly where stress concentrations will occur. Highlighting your hands-on experience with these tools proves to an employer that you can validate designs digitally, which literally saves them thousands of dollars on physical prototypes.
You can design the most perfect part in the world, but if you can't communicate how to manufacture it economically, your design is pretty much useless. This brings us to Design for Manufacturing, or DFM. To do this properly, we use the ASME Y14.5 standard for geometric dimensioning and tolerancing. GD&T is literally the universal language of engineering drawings. It gets us away from basic plus-minus tolerancing and lets us precisely control the form, profile, orientation, and location of a feature.
A highly technical interview might ask you to step through how to set up a datum reference frame. This is a very precise procedure that locks your physical part into a theoretical 3D space by constraining all 6 degrees of freedom. First, you identify your primary, secondary, and tertiary datum features, like a flat mating surface or a mounting hole. Then, you apply modifiers like maximum material condition to ensure parts actually fit together on the assembly line. Know your datums inside and out.
Section 3, Diverse Industry Career Pathways, the Application. Let's look at where you can take all this knowledge.
Let's say you're interviewing in marine engineering. Out there, you are fighting a relentless battle against a harsh, highly corrosive environment. You have to ensure structural integrity under massive ocean pressure while optimizing fluid flow for propulsion. Whether you're aiming to be a naval architect or a marine systems engineer, the ocean is going to test your mastery of flow dynamics and material science every single day.
Or maybe you're looking at health and biomedical engineering. This field is absolutely fascinating because it's where biomechanics meets incredibly strict regulatory compliance. You aren't just designing a simple mechanical hinge, you are designing a prosthetic knee that must endure millions of fatigue loading cycles without failing, all while being perfectly biocompatible. In this industry, the human body is the ultimate design constraint. And if heavy industry is more your speed, mining engineering relies heavily on mechanical engineers to safely optimize massive extraction machinery and complex ventilation systems. Here, you are dealing with extreme load cases, heavy machinery design, and hardcore thermodynamics for deep underground ventilation. The scale is massive, the stakes are very high, and ensuring safe, sustainable extraction requires top-tier mechanical optimization skills.
And that brings us to our final section, professional growth and ethics.
This quote from ASME hits the nail on the head regarding the toughest dilemma you'll face, balancing speed to market against public safety. This is exactly why we use factors of safety. A factor of safety is simply the ratio of a material's failure strength to its allowable stress. We never design exactly at the failure limit, we over-engineer to account for unknowns. So when management pushes for a shortcut, a professional engineer holds the line and relies on that math to guarantee a safe product. Interviewers love to see this mindset.
To build that technical intuition before and after the interview, you need to tap into the engineering community. You don't have to solve everything in total isolation. If you've got a highly technical stress calculation question, Engineering Stack Exchange is deeply analytical. If you need career advice or interview tips, the Mechanical Engineering subreddit has over 400,000 members ready to help out. And if you are dealing with complex codes, EngTips is packed with licensed professional engineers who have literally seen it all.
I'll leave you with this scenario to chew on for your next interview. When management demands a shorter timeline, will you compromise on design or will you protect the user? Remember, your technical skills get you the job, but your professional resolve is what defines your legacy. When you're answering these questions, don't just memorize definitions. Connect your answers to real applications, use concrete examples, and always explain your thought process out loud. Subscribe for our next explainer where we'll be covering mechanical manufacturing interview questions, CAD design questions, GD&T, FEA, and automotive engineering interviews. Until next time, keep analyzing and never stop learning.